All right, why don't we get started? So welcome to CC Colloquium for April 6th, 2022. We have, as you are probably aware, an in-person guest who flew all the way here from Virginia. And not only did she do that, but she opted to fly a red-eye flight to do this, to save us money, which is like really kind of nice. And even though we were willing to pay for a more expensive ticket. So thank you very much in advance. A couple quick announcents. Virtual Night Sky is tonight, and Earth and Space Open House on Saturday from 11 to 1. Yes, so Saturday from 11 to 1, Earth and Space Open House here at ISB4. Right outside of ISB4, and there will be 2 Marston Theater 3D shows, so spread the word. Earth and Space Open House Saturday from 11 to 1. And so with that, no other announcements that I'm aware of. So I'm going to turn this over to Professor Bothekar to introduce our guest.
Good afternoon, everyone. It's my great pleasure to introduce Professor Kelsey Johnson, who is visiting us from University of Virginia. Kelsey got her PhD from University of Colorado Boulder in 2001. Then she was an NSF fellow, and then a Hubble fellow, and finally, from where she is now, she is a professor at University of Virginia. Kelsey is known for many things. Some of that I can only include a few. She is a world leader in understanding how stars form, especially how clusters form and how they grow, conditions that allow that. She has studied a wide range of conditions, some of which she might be telling you about, or other things she'll tell. She is also very vocal about public policy. She has been appointed by the White House Office of Science and Technology Policy to the Astronomy and Astrophysics Advisory Committee. She is the president-elect of the American Astronomical Society. She has also won many awards, like the ACC Distinguished Professors, which is the Atlantic Coast Conference of Universities. There are many other things, but one of the things Kelsey is very, very passionate about is dark skies and how we can generate interest and passion about astronomy among young folks. Without further ado, let me give the stage to Kelsey to talk about all these interesting things she has been involved in.
I'm not talking about any of those, actually. Thank you so much. So I want to right off the bat, thank of those of you who are here in person for actually coming in person. Hello, folks out in Zoom, if you're out in Zoom. I'm glad to have you, and I hope you'll ask questions and laugh at my jokes, even if I can't hear you. I want to start out by saying that this talk is an experiment. And for those of you who are experimental scientists, know some experiments fail. So we will see how this goes. So when Ariel invited me out, he encouraged me. He said, "We'd love to have you out. You can talk about anything you want, but make it broadly accessible to people." And I thought, you can hear an astrophysicist talk about astrophysics like any day of the week. So why would we want to do that? So instead, I'm going to talk about something completely different that I hope you will find actually has a lot of connections to your own lives as scientists and your experience. So like I said, we'll see how this goes. I do want to, I have an ask of you, and I do want to ask you to sort of be co-conspirators in this with me. This is kind of like an academic side hustle. And I really want your thoughts and your input and your take on it. So the ask starts right away. So before we do anything else, I want to ask you to read through this assessment. This was actually developed by Michelle Chioda, who is faculty here at ASU. So if Michelle's online, I have no idea, but know you have a big fan in astronomy. I've read many of your papers, but she developed this assessment. And I want you to take a minute and read through these questions and figure out where you would land. Knowing as you read through that really these correspond to a 1 through 7 scale, right, where 4 is in the middle. And I'm not going to ask you to, I thought actually asking you to do this on paper and collecting them, but I would probably have to fill an IRB, and I don't want to do that. So just get a sense of where you land. How predisposed are you actually to experiencing awe? And in fact, the fact that I'm telling you this is even to figure out how predisposed you are to figuring out how predisposed you are to experiencing awe already kind of ruins the experiment because you know what it's for, which is why I don't have a PhD in psychology. But I want to give you just a sense of this. All right, has everyone sort of read through it, figured it out? All right, you can always look up Professor Shioda's paper if you want to. Okay, so tuck that figure away in your brain. We're going to come back to that. So I've been thinking about awe for a very long time. And as I think about awe, I often think about my own experiences of awe in life, and I hope you will do that as well. But I wanted to share with you actually one of my very first most profound experiences with awe that I experienced as an adolescent. This was, I have to be clear, this was before I knew any astronomy, because if I knew astronomy, this would be in a very embarrassing story. And this was the kind of awe that like knocks you to your knees, takes your breath away awe. So it was super late at night. I won't tell you how late. I grew up in Minnesota. It was the winter. It was the dead of winter. It was probably like January. And I was leaving my boyfriend's house. And I turned north on the road and I saw something like this. The reason it's important I told you I didn't know any astronomy is I didn't know what it was. You might think that growing up in Minnesota, one might learn about Northern Lights or Aurora in school. I had not. And I saw them and I had no context to place it in. I literally was aghast. And I was convinced it was one of two things. This has to do with availability error. It was either God or aliens. Those were the only two choices available to me at the time. Turns out neither of those were true. Okay, so this was like, for me, like whenever I think about awe, I think about that was what I felt when I turned north and this is what the sky looked like. Before we talk about some of the research on awe, though, I want to give you a little bit of background on the landscape and how I came to be studying this at all. I'm kind of a junkie for interdisciplinary thinking. I love talking to people from other departments and hearing what they're working on, what they've learned, what's new. And a few years ago, I became involved with a group at UVA that is working on a project called the Sanctuary Lab. And what they're doing is thinking deeply about what make places on Earth sanctuaries, and why some places and not others. And it's just this very cool interdisciplinary group. It has religious studies scholars, it has musicians, it has environmental scientists, it has me. You know, it's just a really fun group to be part of. And as we were talking about what make places on Earth sanctuaries, I feel like the on Earth there was gratuitous. What make places sanctuaries, it quickly became apparent that awe plays a role in this, and places we consider sanctuaries or not. And suddenly we found ourselves in this spiral of thinking about awe from all different disciplinary perspectives and its role. So we spent a couple of years really digging deeply into the literature on awe, which turns out isn't actually very extensive right now, so that's not as hard as it sounds. Get our head around this. Okay, so a little bit of history, just to set the groundwork. One is, what do I mean when I say awe? And it occurred to me that I really needed to define this a little bit as I was packing for the trip. My 9-year-old daughter came up to me and she was very unhappy that I was leaving, as 9-year-old kids tend to be. And she's like, well, what are you even going to talk about? And I said, I'm going to talk about awe. And she's, no, what are you going to talk about? Like, I'm going to talk about awe. And she's like, well, what is awe of what? And I said, I'm going to talk about the importance of awe in sciences. And she's like, what does that even mean? And I think she's just being snarky. And she's like, no, I don't even know what awe means. And so it occurs to me that that's actually part of the problem, is defining awe. So don't worry, we're going to do that. The word awe itself has actually gone through a pretty huge semantic drift over time. Back in the olden days, so starting in like circa 1200s, 1300s, awe really meant just something negative. It meant fear, terror, dread. It was something that had really predominantly scary connotations. As time that evolved, it became largely because of its association with religious experiences or experiences deemed religious. It also brought into it sort of a sense of admiration or veneration. And now, you know, it's evolved even more. And today I feel like the word awesome is actually really annoying. It's like so overused, it almost doesn't mean anything at all. And so part of the problem that we're grappling with is that the modern colloquial use of the word awe doesn't mean what we need it to mean when we're talking about awe, and what awe really is. I would also invite you to consider the radically different meanings between the words awesome and awful, right? I mean, that alone tells you how divergent the language has evolved over time. So the real research on awe is actually relatively modern, but even in the late 20th century, some of the great thinkers were talking about themes of awe. So we have Durkheim and Weber and Burke and Maslow, all had things to say about an awe-like experience. And so there are a few times in this talk where things I actually want to read to you, which I realize is not super normal in a science talk. This isn't a super normal science talk, so hopefully you'll roll with me on this. But like Durkheim, all right, I know he has gendered language here. There's nothing I can do about it. He's dead, so we can forgive him. A man who experiences such sentiments feels that he is dominated by forces which he does not recognize as his own, and which he is not the master of, but is led by. The individual forgets himself for the common end, and his conduct is directed by reference to a standard outside himself. So he's starting to talk about awe, and he's starting to talk about awe in the context of sociology and social structure. And then we have Maslow, the famous psychologist. If any of you have a background in educational psychology, you've probably experienced him as well. And he starts relating awe to something he calls peak experiences. The emotional reaction in the peak experience has a special flavor of wonder, of awe, of reverence, of humility, and surrender before the experience as before something great. It turns out many of these themes actually still hold through the modern studies of awe. Okay, so the first modern study of awe that really kicked things off was this paper by Keltner and Haidt. It was in 2003, and I want you to know that that was not very long ago, at least for someone of my age. Maybe for the grad students now, they're like, that was before I was born. And the way Keltner and Haidt, they sort of set the stage for the study of awe by trying to really give it a robust definition. And the way they defined it as this confluence of what we're going to call accommodation with vastness. Now, when we talk about accommodation, what we mean there really comes from Piaget, another famous psychologist, talking about what happens when you have sensory input that doesn't fit into your existing mental schema. And so to accommodate that information, you have to adjust your mental schema to take it in. And the other piece of this is vastness. Now, vastness, I think, often refers to size, right? So clearly there are things that are large that might be awe-inspiring. I'm carefully avoiding the word awesome here because I just can't stand it in this context. But by vastness here, they actually mean something much more broad, much more capacious. And that is something that's more conceptually vast. And it's beyond your normal experience, whatever that might be. And you can be beyond your normal experience in a variety of ways that we'll look at. So this study then kicked off kind of the whole like cottage industry of studying awe with actual data in an actual scientific way. So here are all of the papers, all of the peer-reviewed papers that have awe as a keyword since the early 2000s. You can see I have read all of these, which normally might sound like a bragging right, but actually the point of this is to say the scientific study of awe is actually still really in its adolescence, if not in its infancy, right? So I'm going to share with you now some of the results from this research that has happened over the last 2 decades, but there's a lot of questions out there that need to be answered, right? So in the Q&A at the end, and I hope you actually have Qs, I suspect a lot of the answers I'll give you are, we don't know. That's a great idea. Let's study that. So over the course of the last few years, I've read all of these papers, I've read a couple books, I've read 2 PhD theses, both of which are from like the last 2 or 3 years. So that's how I've come to be here talking to you about my side hustle in academics. Okay, so before I even tell you about some of the research results, what I want to ask you to do as scientists, and if you have something to write with, I would even invite you to write this down, like if you're taking notes, or if you're not taking notes, shame on you. What do you think, what characteristics do you think make a good scientist? What are those? And how you answer that actually has wide-ranging ramifications, right? Think about what are those characteristics? And we can talk about, are we really testing for those? Is that how we let people into grad school? Is that how we progress careers? All those things are important side questions, but what characteristics make good scientists? And I want you to think about that before we talk about the results of awe, because I want you to have already laid claim to that before we get into this. All right, the first thing I'm going to do is just give you a quick overview of some of the general results from awe, and then I'm going to tell you some of the things that I think are really specifically oriented towards science. So generally, here's a laundry list of things that research, like actual research, has shown us that awe can do, right? It can expand your sense of time, right? So suddenly you feel like you can take a deeper breath and you can kind of settle in a little bit. It can facilitate really good decision-making and help control your biases. It can decrease materialism. And the flip side of that is it can increase life satisfaction, which is pretty cool. It can encourage pro-social behavior. What I mean by that are things like compassion, generosity, things that we generally would like people around us to have. It can impart an awareness that we're part of something bigger, so it gets you out of yourself and gets you thinking that you're part of a citizen on planet Earth. It actually has biological effects. It can reduce inflammation by sort of tamping down on this pro-inflammatory cyto thing. It can increase humility, which isn't really surprising because you're in the face of something grand and vast, and it can spark creativity. And the list goes on, actually. This is a much, much longer laundry list that has come out of those several dozen papers since the early 2000s. But I think that there are some things that are very specifically important to science. And that's why I want to bring this to you, because I think that there's something we can do as scientists that will actually help the field of science and help us as scientists. And I think we have a vested interest. So here are some things I think are actually specifically important for science. And this is where I would invite you to think back on that list of characteristics that you may or may not have written down for what you think. It enhances creative thinking. It helps you revise your mental schema when your results aren't what you think they should be. It helps reduce your persuasion from weak arguments, right? And helps you think more critically. It helps you make better ethical decisions, which I think is really important for our field. It promotes humility, which may or may not be a problem for scientists, but I think scientists by and large are not generally known as being humble people. Maybe that was a low blow. I'm sure that doesn't apply to anyone in the audience. It's very good at improving your awareness of gaps in your knowledge. Again, I think really important when we're doing science. It can impact the outcome of scientific learning, which is particularly important, I think, for science literacy and our teaching and our classes, both at the college level and in K-12. And it's correlated with a better understanding of the scientific method across the board. So these are things that I think are actually really important for science. So these are things that are demonstrated with research to be true. There are a lot of things that are not yet demonstrated by research to be true, but that I hypothesize may well be true. So these are some things I'm actually really interested in too. We don't know the answers. I suspect that experiencing awe at some level, especially as a child in the natural world, may well encourage science as a career. I think that experiencing awe will help to promote, I would say, more balanced collaborations and inclusion. I think it will enhance teaching and mentoring. I think it will improve scientific literacy. I think it will mediate the effects of burnout. We're going to talk about burnout later, especially in this quasi post-pandemic state that we're in. I think it provides motivation and inspiration for why we do this at all on a daily basis. Okay, so what I want to do now is talk about, okay, so let's say we accept that awe is important. How can we induce it? Now, what the research shows us is that what induces awe in a given person is going to vary. It's likely to vary perhaps along socioeconomic lines, on culture, on any of these different axes that have been part of your life to date. And so I'm going to share with you a whole bunch of different things that I think are kind of awe-inducing. You may or may not find them to be awe-inducing, and we can part ways there. That's fine. Okay, so the first one is, I have to start with astronomy. I feel like astronomy is like dripping with awe-inducing concepts and images. This, I think, is one of the most awe-inducing images ever taken in astronomy. Actually, there's a picture of it just outside the doorway here, so hopefully everyone has seen it. This is the Hubble Ultra Deep Field. This is awe-inducing, I think, for me, for a couple of reasons. One, because we're looking back in time, like 10 billion years, and that almost everything in this image, except for the thing with the little diffraction spikes, is an entire galaxy, right? Like, how does that not actually blow your mind when you step back and think about it? I think sometimes as astronomers, we get down in the weeds and everything becomes coding this, and we're almost become detached from what we're actually studying. But take a step back and think about what we're actually looking at is a little bit crazy. One more, I guess this is astronomy, it's solar physics. Perhaps some of you experienced this, the Great American Eclipse. I suspect more people in the country experienced awe on this day than perhaps any other day in modern history. And so you can imagine what experiencing a total solar eclipse would have been like, thousands of years ago before people even really knew what caused them. And I imagine the awe that was experienced at that time was actually quite substantial. So we won't have another one of these for a couple of years. So good, well, in the US, you can go get on a boat or something if you want to do one. But of course, in your backyard, well, not quite your backyard, it's a little bit of a drive, but there's the Grand Canyon. If you live in Arizona and have not yet been to the Grand Canyon, I feel like publicly shaming you. This is, of course, one of the most awe-inducing vistas in the United States. And of course, sorry, of course, my earring is starting to fall out right now, which is not awe-inducing at all. Sunrise up the Grand Canyon. I mean, if this doesn't take your breath away, I feel like you don't have a heartbeat. But maybe grand vistas are not your jam. Maybe it's age. Like, okay, you're like, what is this tree? This is the Methuselah tree. This tree is almost 5,000 years old. Like, let that sink in. What this tree has experienced in 5,000 years, like, oh. Or maybe really big things. So here's one of the giant redwoods in California. It's hard to get a sense of scale here on the screen. I think it's much, obviously getting a sense of awe in person is maybe a little bit more effective than me showing you a picture on the screen. But just to give you a sense, like if you can imagine looking up at this vast forest canopy of these just giant trees. So these are some of the things in the natural world that I find like just blow my mind. It doesn't have to be a natural world. What if it's a concept? Like this equation. You'll know this equation, Euler's equation. I think this is the most beautiful equation in all of math. In fact, if I were going to get a tattoo of an equation, this would be that equation, right? It's all of the 5 fundamental numbers in math that come up in the universe over and over and over and over again, like in this nice, tidy little simple looking equation. They're all related to each other. Like, how crazy is that? So maybe you don't like equations and there's too many variables or something. Well, actually, nothing's in here a variable. I don't know what I'm saying. Infinity. What about the concept of infinity? Right? Do you ever really think about infinity and let yourself go there existentially? I mean, that's kind of mind-blowing. Or maybe you don't like concepts and you hate math. Maybe you like art. Now, I feel like picking art that you think is awe-inspiring is a very personal choice. I don't know what I thought I want to pick something that's awe-inspiring. What am I going to pick that isn't like, I don't know. I'm not an art historian or a psychologist, so this is where I'm really getting in trouble. I love Escher painting because there's something about his work that I think invites you to think about the impossible, right? So even simple things like this, like just make you stop and ponder and dwell on it for a moment. And so awe can be found in art. And whatever your particular art is, I leave that to you. Or maybe it's something humans have made. This is the Cologne Cathedral, which I think is, I don't know, can you see the little like bitty people down there at the bottom for scale? Right, so one, it's huge, right? It's absolutely phenomenally huge. I think it's one of the biggest cathedrals in the world. You can see the tiny little people at the bottom. So that itself is awe-inspiring. But this was built in the 1300s, right? Just the fact that we pulled that off without modern machinery in the 1300s, I also find to be kind of awe-inspiring. Or maybe it's something humans do. Sometimes sporting events, you're like, whoa, how did that person do that? So maybe it's some kind of human ability. Like I watched this dude dancing and I just can't, I feel like he's breaking the laws of physics. And I am not able to accommodate this in my mental schema. Maybe instead of human things, maybe, the universe isn't your jam. Maybe it's the microscopic, right? So in the, their entire cosmos in a petri dish, right? I don't know how many of you have a microscope at home, but I could spend hours just looking in a microscope, watching little things happen. I'm like, wow, all of that is happening beyond our perception at the microscopic level. And so for me, I also find that awe-inducing. Other things that are beyond our normal senses. So for example, maybe you need to slow down time to see something that you can't see because it happens too fast in reality. So something simple like water drop. Like, I feel like this is mesmerizing when you look not only at the aesthetics of it, but then of course my mind as a trained physicist is, whoa, the fluid dynamics are so cool. And like, I mean, it's gorgeous. And all you had to do was slow down time to really see this play out in its glory. Or the inverse of that, another thing that is beyond our normal perceptual abilities, what if we speed up time to see things we can't normally see? And this is something that I actually hope is happening in my garden right now. I planted some things before I left. I feel like it's they almost look like they're sentient to me when they're growing. And they're searching around for nutrients and light sources. But all you have to do is speed up time to see things like this unfold. Awe can take many forms, of course. It's not necessarily visual. It can be through any sensory input. And so I also want to share with you some sounds that could induce awe. And I'm actually going to turn the volume way up. I thought about doing this without warning you, just to see what would happen and wake people up if you had fallen asleep. I hope this works for people who are online. So this. I love thunderstorms as a kid. In fact, I still love thunderstorms. There's something about that rumble that nature has this unfathomable power that you can do nothing about. It's going to do what it does. And you hope that the lightning doesn't actually hit you or your house. But there's real power there. And there's real beauty that I find to be awe-inspiring. Or maybe it's music. I actually looked really hard for a good timpani riff, and that was the best I could find. Or maybe it's a different kind of music. So this is just to illustrate to you, there are so many different ways that you could try to induce awe. And it doesn't have to be something grand. It could be something small, right? It could be just a water drop on the window that fascinates you. It could be the fractal structure on the back of a leaf, right? These things I think are flashy and they're better for talks than if I showed you a water drop on the screen. Okay, she's lost her mind even more than I thought she had. But there are lots of ways to induce awe. And guess what? They've studied this. So these are a whole list of things. And in this study, this is how frequently they triggered awe in people. So at the top of the list, we have natural scenery. I actually don't know what's in other. Be good to know. Something not on this list. A great skill. So I'm thinking of that dancer who I still think is defying the laws of physics. An encounter with God. I feel like if I had an encounter with God, that would probably definitely enhance my awe experience. But there's a whole list of things here. And the reason I'm showing this to you is that I do wonder about the extent to which this histogram plays out the way it does because of the access people to have to these different experiences. So experiencing natural scenery, that's not too hard, right? All you have to do is go outside and find some natural scenery. If you can find the Grand Canyon, that's great. But if you can find a leaf with a cool fractal structure, that's cool too. Maybe you don't have leaves with fractal structures here actually, because we're in the desert. You might need to find a deciduous tree for that. But some of these, I think we can capitalize on in science. So for example, a grand theory or an idea, like Euler's equation. That's cool. Or black holes, like what happens inside of a black hole, or what caused the Big Bang. Or an epiphany, right? For those of you who are teachers, when you have been working with the students in your class on a challenging concept and you get it, like that moment of getting it where you almost feel the gears like click into place, Like, that's pretty extraordinary. So these are some of the things I think, like, if we as scientists have a mind to, they're like, you know what, I'm going to try to induce awe in my students through the lens of science. These are some things I think we can tap into. All right, let's dive into more of this modern research. The first thing I'm not going to highlight everything because we don't have quite that much time. I want to talk about creativity. Creativity is really, really important. I think it's more important than we often give credit to in science. And the ability to think outside the box and have creative fluency, I think, is essential. So there's a pretty well-grounded research in creativity and psychology, and we're not going to go into that. But in this research in psychology, creativity really takes form in this four-dimensional model. So there's sort of four axes along which creativity can be measured. We have fluency, so that's how many ideas you come up with. Flexibility, so how many different ways are you going to try to solve a problem? Originality, I mean, how rare or common is the idea you come up with? And elaboration, so how much detail do you go into with your, with the idea that you create? Now, this is kind of a table I don't intend you to read. The reason I'm showing it to you is only because I want you to get that there's actual data with actual error bars on it. Before I show you, I turned this into a visualization. Maybe this is endemic to astronomers, I have no idea, but I really need to see graphs and plots for me to internalize things. Like, I could stare at this table all day and be like, I don't understand. So I've taken this data and made it to my own plot. So this is the author's data, but I just needed to visualize it. And this is what it looks like. So when people were induced into an awe state or left in a neutral state, they were asked to go through this creativity assessment. And across the board, in all four of these different dimensions, people who had been induced into the awe state did better. I do want to share with you for fun, because I actually think this is kind of funny. The neutral condition, right? You always have to have a control sample. The neutral condition for this study, I don't remember the awe condition, but the neutral condition was watching hens wander around the field, which I think is I actually feel like that would be kind of awe-inducing. I love watching animals. Okay, so this is one study that looks like it's relatively clear evidence that inducing awe will enhance creativity. I didn't pull data from this one, but I did want to share with you, this is very relevant, I think, for Arizona and people who like to go hiking. And when I lived in Arizona, I like to go hiking, so I just assume everyone else here does. This study was really fun. So what the author did was they took groups of people who were going to go on 4-day hikes. And for the control group, they did an assessment of creativity before they went on the hike. And then for the actual group, they did an assessment after they came back from the hike. And what they found was that the people, after they had gone on the hike, the 4-day hike, had a 50% improvement in creative problem solving ability. So this isn't directly correlated with awe, but it is directly correlated to exposure in nature, and exposure to nature is correlated with awe. All right, awe also has an impact on critical thinking and science literacy. So again, here I'm going to share with you a table that I don't really intend for you to read, but again, just to impress upon you that there is actual data with actual error bars and things like that. And then I'm going to turn it into a plot, really for my sake, if not for yours. So in this particular paper, there were a number of different studies. There are 4 studies here. And study 1 is what I'm going to focus on. 1 had to do with the correlation between these emotions and your understanding of a scientific method. Study 2 had to do with these emotions and your openness to new experience. Study 3 had to do with whether the extent to which you believed in science providing answers. And I don't remember what study 4 was, but we can look it up. So I'm just going to zoom in on study 1 here because I feel like your understanding of the scientific method is pretty important to science. Maybe that's a naive view. So here are how those different emotions correlate with your understanding of the scientific method. Awe does a great job. Interestingly, joy tanks it. Like, you induce joy in someone, they're like, yeah, whatever you want to do, cool. Joy just was apparently, if you want people to think scientifically, don't make them happy, I think is maybe the takeaway from this. And then, some of the other ones have a little bit of signal. There's a little bit of an anti-correlation with belief in God. But awe here is the clear winner, right? To get people to think scientifically, awe as an emotion had the biggest effect. So for this study, let me walk you through it a little bit. The idea here was to look at how, if you induce people into different states, different emotional states, how capable are they of assessing the weakness or the strength of an argument? And so there are a bunch of different states we'll look at. I pulled out these three because I think that they're the most telling in the plot. So we have awe, we have nurturant love, which is different than attachment love. Nurturant love is really when you're taking care of someone as opposed to you want to date someone, right? There's kind of a difference there. Actually, I would say if you just want to date someone, it's probably not love, but that's not for me to judge. The control here, I think I really want to, I don't going to read the top two to you, but the control, please try to recall the last time you did your laundry. So I just thought that was, so if you can all sit here and try to recall the last time you did your laundry, hopefully for some of you, it was sooner than too long ago. So on this next slide, I actually want to share with you, and this is a big, I just want to warn you, it's a big chunk of text and I'm going to read it, but this is the weak argument. And I want to read it to you because I want you to get a sense of what the weak argument looks like before we look at the extent to which people bought it. I also want to share it with you because they, in this made up weak argument, they totally throw the University of Virginia under the bus. And so I was like, wait a second here. Okay, so the idea is the participants in this study were told that university administration was considering implementing a comprehensive exam for students to graduate from college. And then the regents were thinking about it. There was kind of a vague timescale. So think about it as a college student. You're told there may or may not be a comprehensive exam before you can graduate. And this is the weak argument for it, which I think is fascinating. Okay, data from the University of Virginia show that some students favor the senior comprehensive exam policy. For example, one faculty member asked his son to survey his fellow students at the school since it recently instituted the exams. Over 55% of his son's friends agreed that in principle, the exams would be beneficial. Of course, they didn't all agree. But the fact that most did proves that undergraduates want the exams. As Saul Siegel, a student whose father is vice president at Disney, wrote in the school newspaper, the history of the exams can be traced to the ancient Greeks. If comprehensive exams were to be instituted, we could feel pleasure at following the same traditions begun by Plato and Aristotle. Even if there were no other benefits of the exams, it would be worth just to follow the tradition. Okay, that's the weak argument. You can see versions of weak arguments play out in the press, on the news. We don't even need to talk about politics. We're in Arizona, so that would be weird. Here's the strong argument. I don't know that I want to read all the way through the strong argument. You're welcome to sort of skim it if you want. I can read it to you later, but it's a strong argument, right? It has actual data, actual facts. It's not like my son's friend said, whatever, my aunt's second cousin saw an alien kind of thing, right? Actual facts. So then, he had students evaluate how strongly or how persuaded they were by these arguments based on the emotional state that he had sort of primed them to be in. And this is how it came out. So the neutral state is on the left, right? It's kind of neither here nor there. The good news with this is that in every case, people thought the strong argument was stronger than the weak argument. So that's positive. But what we see is that, for amusement, anticipatory enthusiasm, attachment, love, and contentment, the weak argument wasn't all that perceived as being all that much weaker than the strong argument. But when you induce awe or nurturant love, there's a dramatic difference. Okay, so I think that this is a pretty fun study, and I think that weak argument is fascinating. Okay, the next axis of awe I want to talk about is awe and humility. Which is kind of a weird thing to talk about, but it is what it is, and I think it's important for science. I think it's important for us not just to be humble as people. I think it's important for us to be what's called intellectually humble, right? To be open to our ideas being wrong, because guess what? Our ideas are often pretty wrong. Sorry, Chris. So there are various assessments that get at this, and one of the ways psychologists get at this is through what's called sort of a sense of self or a diminished self. And I realized that these inventories look a little bit hokey. At least they do to me as like someone who really likes actual data and numbers and not just circles. But they actually kind of work. And so what you're invited to do when you take these assessments is, look at these circle sizes and think about which one you feel best fits you. You're all doing that right now in your heads, right? Like that. Or with this graphic on the right, to think about with, the little human figure and the graphic sun, which of those graphics best represent how you perceive yourself in the world. So one of the things that comes out of the study is that when people are induced into an awe state, they experience a diminished sense of self, meaning they would place themselves in a smaller circle size or in one of the smaller little human figure graphics on that. They are more attuned to the strengths or weaknesses of arguments, like in the study that we just saw. And they have a need for cognition. What that means is a need to think about things. Like they don't want to just like veg out. They actually want to think about things. And this term called existential quest, which is, I think, really funny because when I see existential quest as a not psychologist, I think, oh, I'm going to go read Lord of the Rings. I go like vanquish whoever. So existential quest here actually means the degree to which you are opening to questioning your ideas. Another good term for this, which I think is a word I wish we used more across science and across actually all humanities, is defeasible, right? You say something is defeasible, it means you believe it to be true, but if you saw evidence, that was compelling enough, you could be convinced to change your mind. So that's what existential quest here. All right, so in this study, what they did was look at how using inventories like the ones I just showed you, and having people be exposed to all of these different types of things that could be awe-inducing. How did they rank their self size based on the control? So the control is that dashed line, right? So that is how they would normally perceive their sense of self. And then after being exposed to these different things, well, I'd say it's labeled the United States because this was done in a couple, I think it was also done in China. The studies have some small differences, but they're largely the same. And you can see how inducing awe from a variety of these things actually diminishes your sense of self, right? It induces some humility. You don't feel like you're all that. So there's actually, and in terms of science, there's actually an intellectual humility scale. This is another assessment I would love to give sort of all scientists I know to see how intellectually humble or not you may or may not be. So I question my own opinions, positions, and viewpoints because they could be wrong. I reconsider my opinions when presented with new evidence. I recognize the value in opinions that are different from my own. I accept that my beliefs and attitudes may be wrong. In the face of conflicting evidence, I'm open to changing my opinions. And finally, I like finding out new information that differs from what I already think is true. So you could give this assessment to people you know and love, but they may not know and love you after you give them this assessment, and do various studies on them, which is also a hit with your family. So you can correlate intellectual humility with other properties. So in this study, they took a measure of intellectual humility and they mapped it against both just plain intelligence and then also cognitive flexibility. So I realized, so these two graphics are actually the same thing, this manifests in different ways depending on how you like to input information. But what comes out of this is that intellectual humility is strongest with cognitive flexibility. So the more cognitively flexible you are, the more intellectual humility you're likely to have. Likewise, it actually goes up with intelligence as well. So the most intelligent people tend to be aware that they don't know everything. So the not very intelligent people we have to worry about. So there's a really interesting correlation with cognitive flexibility. And the reason this comes back to awe is that humility has a direct line, of course, back to awe. So in this model by Jennifer Steller, the way this works is you start out with vastness and a need for accommodation, which are the two ingredients that go into awe. And then awe induces the sense of self-diminishment, and then this self-diminishment maps into humility. And what she found in this study is that if you are more prone to awe, so on that dispositional awe scale, you are also likely to be rated as more humble by your friends. It's important you don't do the self-rating. That doesn't work out so well. If you are more prone to awe, you are also more likely to have a balanced view of your strengths and weaknesses. And also, and I think this is really important, if you are more prone to awe, you're more aware of the serendipitous things that have happened in your life that have led to your success if you have success. And I think all of these things are actually really, really important for science. So the other thing that's particularly on my mind right now, as we come out of COVID, is burnout. I don't know how many of you are burned out. I hear rumor that lots of people are burned out. It's a thing, right? It's an endemic right now in higher education. It's actually an endemic like in the entire country outside of higher education. So even before COVID though, right, we were worried about burnout. So this is data from 2013, right? This is pre-COVID. And even pre-COVID, when university staff were asked if they experience levels of stress that they find to be unacceptable, right? How you define unacceptable, I would leave up to you. But to me, that sounds pretty unpleasant. Like if I'm experiencing an unacceptable level of stress, that makes me not want to be part of that thing. You can see that like over 80% of people experience unacceptable levels of stress at least sometimes, if not often, if not always, right? So this is contributing to burnout. Now, then we go through COVID, and I'm going to zoom in on this next plot, so don't worry. I just want to give you a sense of it. So there are these surveys that go out to college and university presidents all the time about what they're thinking about, what they're doing, what they care about. And this is a snapshot of what university presidents were most worried about just this last fall. So in, what is it, December, November, something like that, of fall 2021. And there's this whole long laundry list of things, right, that I know you can't read right now. Again, some of you are trying and you're really good at it. Let me zoom into the top. So these are the top things college and university presidents are worried about right now, or at least they were worried about at the end of 2021. Mental health of students, number one, by far. Okay, then we have enrollment numbers, fine, and then the next three things are related to retention and morale and mental health. So morale of faculty, retaining current faculty and staff. I don't know if you've all heard about this, like mass exodus, like people are retiring when they don't need to retire. Like 50% of college professors are considering like leaving. Like there's massive burnout in higher education. And then the mental health of faculty and staff, right? So 4 of the top 5 concerns of university presidents right now have to do with burnout, morale, and retention, right? So this is a real issue in higher education. So let me share with you another study. So in this study, this was actually a PhD thesis that just came out a couple of years ago. And what she did was survey, I think it's 40 odd scientists from a whole range of different disciplines and a whole range of different years they got their PhD, right? So you want to sample along these different axes about their experiences as scientists. And I want to share with you a couple quotes from this. First, some overall results from this thesis. One is that the participants, so of these 40 odd, almost 50 scientists, they lamented the demands to publish and the importance of pleasing funders as limitations that prevented them from pursuing projects that fulfilled their sense of curiosity and would have the potential to evoke awe. I don't know how many of you feel this, right? The paper and the grant pressure are real, right? And in some ways, I think they really hem us in from doing the things that we want to do, that we love doing, that are creative and inspiring. And then the next thing I want to read you is that several participants also pointed to a sense of competition that dampens their sense of awe, especially in the context of the awe that they might have otherwise felt in response to someone else's success. I think that's no good for our people, right? If we love, for example, astronomy, we should really love astronomy. It doesn't matter who came up with that result, but people tend to entrench and almost feel like another person's success is an attack on them, and we take this defensive posture. So Here's a quote from the pseudonym Francesca. I think that for the vast majority of scientists, it is about surviving in something that has lost a lot of its meaning and has become just something as marketable as anything else. We're fighting to publish so that we can survive to get grants. At the end of the day, science is not anymore a place of awe. Research is a place of struggle. I don't know how many of you feel that, but I feel like it's pretty pervasive. And that really sucks because science is pretty incredible, right? Think about the things we get to do and the discoveries we get to make. For those of you who happen to be observational astronomers, like if you get that data fresh off the telescope of some galaxy 5 billion light years away that no one has ever seen before, that really better induce awe in you, right? So if we get so defensive and entrenched and cynical that we're like, yeah, we just need the grant money, what are we doing this for? Okay, so the good news is that awe can help with this. So I don't know how many of you want to like go in an fMRI and be subject to experiments, but that's what these people did. So they actually put, full on electrode stuff all over your head and your brain and induced different experiences. And what they find is that when you induce awe in people while they're in an fMRI machine, which sounds lovely, what it actually does is it dampens the activity in the default mode network. And what that does is actually sort of pulls you out of yourself. And what it does is it sort of cuts down on rumination and self-focus and pulls you out of yourself so that you can become less entrenched in your own mind. And that then helps fight burnout. That then helps you become less cynical. And so awe can help with this. Of course, a real concern that I have, and I have this concern. No, lots of researchers have this concern and have raised it, and I find resonates to be true with me, is whether or not we are becoming awe deprived. Right? We are so far from what our ancestors evolved in. Right? We are largely indoors almost all the time. We're in front of screens almost all the time. We're rarely, unless we do it intentionally, experiencing things that are overtly awe-inducing. One of the things I think about a lot is how we're losing the night sky. I grew up, as I said before, in Minnesota, and one of my favorite things to do was we had this meadow behind our house, and I had this really old, awful sleeping bag. And in the summer nights, I would go out there almost every night I could and just look at the sky. Just look at the sky and like really sit and think and look at the sky. That, by the way, is the Constellation Lyra for astronomers who don't know your constellation. I put it there because it's my favorite, and it's actually my dog is named Lyra too. And Vega, just so you know, Vega, if you use Vega standards, that the bright square is Vega. I think a lot about how important just access to a dark night sky is, one, to induce awe, but just generally for humanity, like being face to face with the universe, I think really changes your mindset in terms of your importance and the scale of the problems in your life and our role as humans on this tiny little planet. And this is something, so this is actually from, I don't know if any of you have seen, I gave a TED talk on this a couple of years ago, and I pulled this slide from my TED talk. I think being in Arizona and having a share of optical telescopes, most of you here are pretty aware of light pollution and how very, very bad it's getting. But I just want to reinforce that and how bad it's about to get. So this was what it looked like in the 1950s. You could probably find Phoenix on this map, I think, if you looked. This is what it looked like by the 1970s. This is what it looked like in the 1990s. And here's a prediction for 2025, which is like not very far away. So by 2025, virtually the entire eastern half of the United States, where I live, will be perpetually brighter than twilight, which means that basically no one will be able to ever see like the Milky Way, let alone like stars. I feel like this is disconnecting us from the universe in a way that I find very, very troubling. And we won't even go into the satellite constellation thing right now because I'm too tired for that. So this is just one way I mean, the night sky should be easily accessible to people in awe-inducing, and it's one way that we're losing touch with awe. We're also losing touch with awe in a whole bunch of other ways, right? So we are, for example, the average child right now, so scary to me, spends 8 minutes of unstructured time outside a day, like 8 minutes. But I have kids. I actually kind of know that to be true. There's been a 20% decline in per capita visits to national parks since the 1980s. There's been a 25% decline in visits to national and in nature recreation areas since the 1980s. Visits to art exhibits have gone down. Museum visits have gone down. We're just really kind of hunkering down and no longer exposing ourselves as much as we used to these things that even could start to induce awe. So there are things we can do to enhance it. So one of the things I did over a decade ago was I designed an entire course to do this. And that has been a great success. And there are studies that use VR to do this in the lab by using different images that are meant to be awe-inducing. And I think we could even do a better job than we have. And so even using VR with like these hokey simulated images, you can see it just spikes awe up. I've also done a small pilot study with students, and I want to show you the results from before and after the small pilot study. We took them away for 3 days. We took away their electronics, and we spent 3 days doing things meant to induce awe. And in those assessments I showed you earlier, we saw a little bit of motion on all of them. I'm not going to pretend that this is a robust, rigorous scientific experiment. It wasn't. It was just us trying to figure out the landscape of what could work. So I want to go back to this. What does awe do for science? And I hope I've shown you at least some data that suggests all the myriad ways that awe could help science. Everything from enhancing creativity to promoting humility. And then finally, what I want to do is just leave you with what, to my mind, the most awe-inducing image in all of astronomy is, and astronomy is just dripping with awe-inducing images, is this one of the pale blue dot that Carl Sagan made famous. And if you're not familiar with this image, and hopefully most of you are, this is an image of Earth taken from the distance of Saturn. And that little tiny, tiny little speck there is Earth. And I think letting this image sink in and giving you a sense of our place in the universe is one of the most awe-inducing things that I have ever encountered. Thank you.
Much for a very thought-inducing, I will not say awesome talk.
You did it.
I did it, but I didn't do it. I did by not doing it. So questions, we have a couple minutes for questions on the Q&A online, or folks in the audience. If you want to raise your hands, I'll be happy to come out. Yep. Oh, sorry.
Yeah, thanks, Kelsey. It was very, very inspiring. So you showed a set of images and videos, and you said like not everything induces awe in everybody. So when such studies are done, or when somebody designs an experiment to put people in awe, how do you know whether they're in awe or not? Or how did they know, I suppose? Like,
right.
Yeah.
It depends on the study you're talking about. There are various assessments that are given after exposure to something that is intended to be awe-inducing to assess the extent to which awe has been induced. But it really varies study to study.
There's a question online. What's the actual definition of cognitive flexibility, and how is it calculated?
How is it calculated?
Yeah.
Cognitive flexibility, the actual definition, I can say how I would define it. This may not be the actual definition. Has to do with how easily you are able to manipulate ideas and thoughts in your mind and change the way you connect things and the way you think about things. How it's calculated, there's a standard assessment for this. It has 4 letters, a 4-letter acronym, and I can't think of the way. It's actually from like 1974. It's like an old school assessment that that assesses these various levels of things that are considered creative. So there's a huge literature on this, and I'm happy to summarize.
Okay, I'll do another one online and then Steve. Have there been any studies about awe and age? Do kids, for example, experience awe more easily than adults or vice versa?
Oh, that is such a good question. I have not seen one. Certainly there have been studies of awe with adults, and there have been, I haven't actually seen one focused entirely on kids. I think this would be great, right? Because there's something about childhood that I think is very different than when you're like a seasoned, cynical, grown adult. There may well be studies like that underway right now, right? Given the state of awe research.
I could just imagine it might interestingly be the opposite, right? Because what I was struck by is, you know, your first two images, the Northern Lights and the Hubble Deep Field, right? So you don't need to know anything about anything as your situation was to be awe-inspired by the Northern Lights, right?
Right.
But the Hubble Deep Field, I would imagine you need to know a fair bit to understand how awesome that is, right? What's a galaxy, and you know, otherwise it's just a black field with a lot of dots in it, right?
That's a really good point.
So maybe actually people who are older who know more can access that feeling in more different ways.
Yeah, I think it could go either way depending on what the awe inspiration is. Yeah.
So that actually kind of was what I was going to bring up, that there's really two versions of awe. One is visceral and the other is more cognitive, right? Or intellectual. And so I'm curious whether any of these studies evaluate that. Like if it's a visceral sense of awe, is it more impactful? You know?
I haven't seen that teased out. There are some different in the assessments of awe, there are some different questions that I think would get at that, whether it's more of a cognitive or more of a like kind of awe. I haven't seen one specifically tease that out, but I think it's a really good question, right?
And a more generic one, your early slide, it was a Venn diagram of accommodation and vastness, I think, and in between. I didn't understand what accommodation meant in that context.
That wasn't a question, that was a statement. Sorry.
It's not an argument. Yes, it is.
I'm trying to pull it up. Of course, we're asking me to do something on the fly, which doesn't always go well. So accommodation has to do with, it's a term that comes directly from Piaget. So if you want to go read a vast amount of literature in education psychology, but it has to do with, you have existing mental schemas in place that through your life, however long you've lived, have kind of been put in place. And when you are presented with some kind of information of whatever form, if it doesn't fit, right, it's like trying to put a puzzle piece in that doesn't fit into the place where that puzzle piece is supposed to go. It makes you have to revise your mental schema to get it to fit. So it's that process of incorporating new information that almost you either don't accommodate it or it forces cognitive flexibility. Like it's sort of one of those two things kind of has to happen. But one of the really interesting things in these studies of awe is that when you induce this dissonance where people are really called upon to accommodate knowledge, when they're in that state, they're also much more likely to make connections between different things. And so it's a really like beautiful state to induce your students to be in, because when they're in that state, they're much more likely to actually get connections and ideas into their brain that you're trying to get into them, which was actually not what you asked, but really you just made a statement. So I could say whatever I want. Yeah.
Because of time.
Sorry. So one of the traits I think that makes a good scientist, at least in my view, is a sense of curiosity. And I wonder, I mean, have there been any studies at all that have?
Yes.
Okay.
I don't know if I have that study in here or one of the studies in here. It 100% increases curiosity. Yes. Is directly correlated with increasing curiosity. And I should have put that study in. So I told you some experiments fail. Yeah, you're totally right.
All right. Well, we should wrap up in the interest of time. I just want to say this as somebody really serious about science education. What's fascinating to me is that we often talk about using that sense of awe as a way to motivate students to sort of enhance their scientific learning. But what you're showing, or you're bringing us, is information that inducing awe is potentially a very positive end in and of itself because of the what it induces independent of motivation. So that was really eye-opening. So thank you very much. Really enjoyed that. Hope others people did as well. And thanks for coming.
You're welcome.